This is topic 5, energetics. So energetics is really thermodynamics, which is the study of energy and its changes. Lesson 5.1 focuses on exothermic and endothermic reactions. So energy is the capacity to do work or transfer heat. When we talk about energy, we talk about two types: kinetic energy, which is energy of motion, and potential energy, which is stored energy. And stored energy in chemistry is chemical energy, which is energy within the units of chemical substances. It's contained within the bonds. And kinetic energy, when we talk about chemistry, is thermal energy, which is energy that is produced from the random motion of atoms. And the law of conservation of energy says that the total quantity of energy in the universe is assumed constant. The units for energy are joules or kilojoules, and traditionally what you see outside of the chemistry classroom is calories, like the calories on a food package. So 1 calorie is equal to 4.184 joules, and in physics you might actually see a different unit, a kilogram meter squared per second squared, which is equal to 1 joule. The system is the part of the universe that we're studying in thermodynamics. For example, the beaker in which you're performing a reaction. The surroundings is considered everything else in the universe. So there's a few different types of systems. In an open system, you can exchange matter and energy with the surroundings. A closed system allows the transfer of energy as heat, but not matter. The first law of thermodynamics says that energy can be converted from one form to another, but can never be created or destroyed. Enthalpy is the heat content of a substance. In an exothermic reaction, the system loses heat, or it exits the reaction. Most chemical reactions are exothermic. For example, combustion reactions, neutralization reactions. In an exothermic reaction, the system is transferring heat to the surroundings. For example, when hydrogen and oxygen combine to make water, energy is released. The enthalpy of the system, or the heat content, will go down, which means that the change in enthalpy, or delta H, is negative. Another example is in combustion. For example, the combustion of methane to form carbon dioxide and water has a change in enthalpy of negative 890 kilojoules per mole, because the products have less energy than the reactants. In an endothermic process, the system gains heat. Heat is entering the reaction. So energy is being transferred from the surroundings to the system. Enthalpy will increase, so delta H is positive. For example, carbon dioxide plus water will combine to form glucose plus oxygen. The delta H, or the change in enthalpy for this reaction, is positive 2802.5 kilojoules per mole. Another example is when energy is added to mercury 1 oxide or mercury 2 oxide to form mercury and oxygen. Again, energy is added or entering the system, so it's endothermic. The standard enthalpy change, delta H with this little knot symbol at the top, is the energy change at standard conditions. So 298 kelvins, 100 kilopascals, if it's a solution, 1 molar solution, and the substances are all in their standard states. For example, oxygen is usually found as a gas, so that's its standard state.